Hey everyone, good morning, good afternoon, and good evening to you all who all are joining us globally. Yes, I am Parth Varu, event planner for Microsoft Reactor Bangalore. And yes, I welcome you all to yet another session of Tech Espresso. Today we have an exciting session, but before we begin, let's go through our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding of differences, being kind and considerate in a way we all engage. Yes, we do encourage you all to participate to learn together. Please drop all your questions in the chat section and we'll pick up it from there. Now, let's not take much time. I'd like to bring in Docker Captain Ajit Raina. Hi Ajit, how you doing?
Yeah, I'm doing good.
So Ajit, how exciting are we today and what are we learning today?
Yeah, definitely. If today the session would be for developers. So as developers spend so much of their time on the development machine, which is laptop or any of the cloud instances, so I'm going to bring up a lot of new tools which has been introduced by Docker team just to turbocharge their development workflow.
Wow, that's fantastic. So let's not delay anymore. The floor is all yours.
Thank you, Parth. Okay, so guys, let's start. Let's get started. The thing is, as Parth has already introduced, but I'm just going to go ahead and introduce myself. I'm working as a developer advocate at Docker. I'm author of collabnix.com, which has around 400 to 450 plus blogs, which I have written on Docker, Kubernetes, and IoT. I am also ex Docker captain since I am working for Docker. So at the same time, Docker captains are not Docker employees, but they are like an influencers. So I have been Docker captain since last 7 to 8 years. I'm also Docker community leader Bangalore, which is the one of the largest community in the world with around 14,000 members. I'm also part of ARM ambassador, so I work very closely with the ARM community and try to build POCs around IoT and ARM. In the past, I worked in the company like Dell EMC for almost 8 years, VMware for 1.5 year, and Redis and CGI. Now, as I was talking about the Collabnix, there are the so Collabnix is basically a kind of an open source community with around 8,700 members, which are basically in the Slack. And we do a lot of community driven projects. So one of the example is a Docker Labs, which gets around millions of contributions all across the open source, the Docker, Kubernetes, and IoT community. So you can visit dockerlabs.collabnix.com. If you are really interested in Kubernetes, we have a Kube Tools, which has around 400 plus open source tools. So these all the repositories are basically open for all. You can go ahead, you can contribute. And if you really want to get started with Kubernetes, we have a kubelabs.collabnix.com where you can learn and you can have around 100 plus different tutorials on Kubernetes. Now, today agenda is going to be a little exhaustive. I am going to talk about all the new features which Docker Desktop has brought and which can basically turbocharge your developer workflow. So we'll start with the inner loop of Docker development workflow, how it look like. Then we'll jump into how Docker solves that problem. There are a bunch of tools which has been introduced in the latest Docker Desktop called as Docker init. We have Compose Watch. So if you are really a fan of Docker Compose, you are going to love this. And also, we are going to spend today some time on secure supply chain. So I am going to talk about Docker Scout for the first time on the stage, and then talk about the file explorer, which can help you to go ahead and edit those files in the UI. And all of these topics has certain demos, which I am going to go through. Okay, now Docker as a company in past several years have been more focusing on developers. So Docker has already proved itself as a DevOps tool, but right now, if you see most of the announcement which we make today are more centric on developers, and you can clearly see that in a Stack Overflow, we are the most loved, the technology altogether. We have around 20 million plus monthly developers who basically use Docker. There are around 7 million plus applications which are in the form of the Docker Compose, and you can look at the 20 billion plus monthly image pools. Now that speaks around Docker, how it is used in your development, in the stages of the development lifecycle. Now, in any of the developer lifecycle, you have two major phases. One is inner loop and the outer loop. Inner loop talks about, as you are a developer, you have a full control of your development machine, right? Where you build your application on your laptop. And once you build it, you try to push it to, say, registry or container registry. And that is where the outer loop comes into the picture, which basically allows you to collaborate with multiple teams along your organization, right? And that is where the whole process of deployment, the CI/CD, comes into the picture, right? Now, Docker has been releasing the products, the features which target both inner loop as well as the outer loop. But today you will see, like, I will be majorly focusing on the inner loop side of it. The reason being, we have introduced lot of improvements in terms of the build process, and there are tools like init compose watch which helps you to build your Docker image at a very faster rate. Now, if you look from 30,000 feet today, Docker might seems to you in terms of, okay, you build a kind of a, you containerize your application and you start with the Docker build command on your laptop, which basically packages your application as a portable container images, right? And you also create a multi-container application using Docker Compose, and that speaks about Docker Compose build or Docker build, right? And once you have built it, you basically push it to your container registry, which could be Docker Hub or any of the registry of ECR, right? And then each cloud has its own registry. Now, once you share it, then your colleague or your client, your customer might be basically pulling these images and running it, and they do with Docker run command. Now, from 30,000 feet, it might look very simple like this, but as you get into in depth of what are the things which happen in this inner loop, you will realize that you are not the only developers. You have bunch of developers working in some kind of, they are writing their code. They might be using some kind of an IDEs like IntelliJ, VS Code, and NetBeans, right? And then they are committing those changes, and that changes basically might go to the build server, which could be today, GitHub Actions, right? Where you just go ahead, push your source code, and then it tries to build your Docker file, it push it to the container registry, and then it gets deployed. So the entire build process looks something like this, which developers really has to take care, because what we are talking about is an inner loop. Now, in the inner loop, a developer might be working with the, might be building the tools, and they might require the necessary tools to build it at a faster rate. Now, let's imagine a typical Docker workflow which use all these programming languages. You might be at the same time Node.js developer or Python developer or Go developer or .NET developer, right? But the sequence remains same. You have to start writing a Docker file, building it to Docker image, and run it as a Docker container. Now, let's look at very simple Node.js based application, right? I picked up Node.js because this is something which I have been working on recently. And if you look at the simple Node-based application, Node.js-based application, what do? You basically clone a repo. You try to use the npm command. You basically package your the whole application. You install the necessary package, and that builds your package.json file. And you try to run the server.js basically to bring up your typical JavaScript-based application. And this is how the steps look like. Now, if I try to go ahead and containerize this application, what I'm going to do? The first thing I'm going to do is creating a Docker file. And in the Docker file, what you do, you start with a base image called as node. Considering that the best practices right now are not in a place, but we are starting with the day one of your day one of yours, basically containerizing your application. So you start with the base image, you specify the working directory. So okay, so all of my applications should sit on user src app. So that is what you specify. You copy the package.json because that is what you use npm i command to go ahead and install those packages. And then you copy all the source code, put it inside the container, and you expose it in port 8080. And at the end of the Docker file, you specify, okay, I want to run this particular script, which is like a server.js. Okay. And to build this image, I use Docker build command and Docker run command to be like to show you a very simplistic way of how you containerize any application. Now, during the course of time, Docker is not about just building and packaging an application, but also there are do's and don'ts. And that's where your best practices come into the picture. Now, whenever you are containerizing an application or building a Docker file or writing a Docker compose, there are best practices which you need to we need to go through. The first thing is you need to ensure that, if you see, one of the basic functionality of operating system is that if you have an application process, it should not basically retrieve all the memory or CPU from the other process. It has to be constrained, and that is where your mem limit comes into the picture. So when you are running a container, the best practices says that you have to run it as a non-root user, or you have to basically ensure that there is no vulnerability in your Docker image. There should be a multi-stage build, right? And there are few of the don'ts, like, okay, you should not use always the latest version, because the latest version is sometimes it is not tested, and you are not you don't have any control over it, right? Because there are new additions of the packages which gets added to the image, right? And the other thing is, you should not expose a database port. Why you should expose a database port? Because the thing is, it might expose to the external world, right? Now, if you go one by one, I have written a blog. If you go to the Google and type 9 tips for containerizing a Node.js application, you will end up in this blog, which is published in the official Docker website. And let's go through each one of them, because this is really important. The first thing, as I said, whenever if you see the initial example, the day one, right, when we started with picking up a node based image, which says like, okay, when you say just node, it basically picks up the latest version. And one of the best practices, you should explicitly refer or the base image reference instead of the latest. The reason being, you might test your application with a particular version, and there might be tons of images which gets added which could be vulnerable, right? So it is always, and there is always a dependency, so it is always recommended that you pick up a very specific version, so that you have a specific control over that particular Docker file. Otherwise, every new door there is a new packages or the files gets added to your base image, and it might corrupt your whole it might raise a dependency issues. At the same time, the downside of the latest images is that it is inconsistent, it is non-deterministic, because you don't know what has added to the latest image. The other thing is, whenever you pick up the images, you should pick up a linear Docker images, which means that say if I'm building an application, it doesn't make sense that I should pick up the full-fledged application. I might be interested in few of the pieces which are important for my application. One example is, say you are building an image, and I picked up just an Ubuntu. Now Ubuntu comes with like around 700 to 800 is basically the minimal images. So I might not need that, right? I might be developing some kind of an application, say AI based application, which might use NumPy or Jupyter Labs and all of these things, right? So I just need those packages which is very slim trim, so that linear your Docker image, the faster the rate it can basically run on your machine. And as I can show you, like when you have a larger download size, so if the bigger the image is, it takes time to pull from Docker Hub and again run it on your machine. The other thing is, the more the services run on your containers, there are more chances that you expose it to vulnerabilities, and then definitely you have 100 of services running on your container, then it might consume more CPUs and RAM. So this is one of the example which I have shown you, when you have a Node.js slim version, which is just like 62 MB, whereas if you see 16.17, which has more like 333 MB, like which is again is going to take more time. Multi-stage build, we have already been if you have used basically you have created Docker file, about a multi-stage build. So sometimes what happened that when you build a Docker image, most of the time you pick up those images, you run apt-get update and all of these things inside the Docker image, which might fetch all the unnecessary package. So what we do, we basically create a multiple stages. So first is the builder stage, where you try to pick up all these images and then try to build it, and then you can use a docker ignore just to ignore those packages. And then we have a second stage which is called as the development stage, which means that you only need those packages which you require, and that is where you can define the multiple stages, say dev, prod, stage, all the three environments you can specify through multi-stage build. And with multi-stage build, you gain optimization. Your image becomes smaller in size. The reason being, it is optimized. It only has those packages which is required. The third thing is talking about especially the scanning the images. We have seen there are multiple layer of vulnerabilities which you can use. So for our example, we will going to use, I do have a slide for Docker Scout, which basically lets you to have an inbuilt scanning tool rather than referring to any of the third party tools. The other thing is, in a Docker file you can also use a health check. Health check means that if you really want to ensure that your application is always up and running, you can add this parameter health check, which basically always try to ping your local host at this particular port in a specific time, and then you ensure that your um, container is up and running, right? And this is one of the example where you can see in the Docker ps command, you can see the health as starting, which means that you have still that option where you can ensure that your application, your front end is up and running. We have a docker ignore, just like a git ignore. We have a docker ignore where you can ignore those packages, unnecessary packages. So docker file, so docker as one of the best practices that you should have some kind of a practice to use it regularly. Now this is obvious that most of the time it is said like Docker is not secure. The reason being, you don't have specific tools, or you don't use those features. So one is, you can even run your container as a non-root user for security purpose. So this is one of the example where I am adding a user called as VS Code, and I am also adding it to the group called Docker, and then ensuring that this particular container runs as a user and not as a root. One of the best thing which I have seen in the Docker, like as I'm working on multiple platforms like IoT, laptop, and the cloud server, is a multi-architecture support. So think of it as like when you build an application on your laptop, and if you want to run it on your Raspberry Pi, with the tools like BuildX, you can specifically go ahead and run those kind of a Docker images. So it is always recommended that whenever you build a Docker image, you should build it for both the architecture, AMD as well as ARM. And then the second last point is, the ninth point is using an open telemetry API. The reason being, when you build a Docker image and run it as a Docker container, then sometimes what happened that your application might go slow, right? In that case, uh, there are tools like Signos and the telemetry, open telemetry, which you can use to ensure that your application runs at an optimal rate, and ensuring that your application is not slow. Because sometimes what happened that when your image gets plotted, it takes time, and there could be hundred of reasons why your system is slow, right? In the same way, your if you have an open telemetry in place where you can use it as an APM, which is application performance monitoring, where you can target all the three things, what, why, and how, which is basically what is like a metrics, logs, and traces. So you can target all of these things. So it is recommended that whenever you build or containerize your Node.js or Java based application, you should use open telemetry to measure the node performance. Now the last thing is, I don't know how many of you know, we do have an health check in Docker Compose. I have seen it is used very less, but yes, it is important. I will tell you that one of the reasons. Say, think of it like, if you are using a Docker Compose file to go ahead and build a microservices, and later point of time when you deploy it on the Kubernetes cluster, then there are chances that those services might be, say you have 100 of those services talking to each other. Now with health check in Docker Compose, what you can do, you basically attach a spec saying like, okay, every 1 minute 30 seconds interval, you should go ahead and ping this particular service and ensure that it is always up and running. Okay, and there is always a retries where it will try to ping it thrice to ensure that your services are up and running. So we do have a health check in Docker Compose. Now, even though we have a best practices, and if you go to the docs.docker.com, you can see the best practices guide. But again, it's still difficult, right? Because you need to go through all those best practices and ensure that these services are up and running. So it is still painful. And for this, we have a tool called as Docker Init. Now, Docker Init is introduced for the first time in Docker 4.18. So right now we have 4.22. and it was recently, like last to last month, it was introduced. It basically, what it does, it generates your Docker assets. So you might have seen most of the time when developers start, they start writing Docker file manually. With Docker init, you don't really have to do it. You just say Docker init, specify your application platform, and done. All those necessary Docker assets gets created for you. So we will see this in demo in few seconds. But Docker init allows you to choose your application platform. As you see here in the screenshot, right now, Docker init supports Python, Node.js, Go, and with the recent um, release, we have also support for Rust. And so which means that if you are any of these developers, you could use it at least to get started or kickstart your containerization journey. So and what are the benefits it brings? So Docker init basically creates the Docker assets. It saves your time because now you don't really have to write something from scratch. Already there is some kind of a boilerplate which is already there to use it, right? And also it helps with the better project organization. Sometimes what happened that when you create a Docker file, you skip a lot of those entries, specifying the volumes, specifying the port, you just miss it, and then you come back and then specify the expose command, whether I should use entry point or not. So Docker init helps you in that. And the best part is, as I talked, right, it takes care of your best practices. You don't really have to go to docs.docker.com and go through each of these best practices, right? So it's a demo time, and let me show you a quick demo. So I am going to click on Docker samples. So if you go to github.com/docker samples/docker init demos, you will see in this GitHub repo that I have a couple of these examples which I have specified, especially each of these languages. So let me go ahead and try to clone this repo. So today I'm going to show you the two of the demos, what is init and scout and compose watch. So let's jump into Docker init. So I have already cloned this repo. Think of it as like if I am inside the Python. So right now, if you see, I have an app.py. Now, if I really want to go ahead and run this application, so let me show you what is an app.py. It is very simple HTTP, the Python script, which basically goes ahead and print hello from Docker and use the HTTP. So if I really want to go ahead and containerize the application, right now I don't have any Docker file or any Docker compose. So what I'm going to do, I'm going to say Docker init. Now, once I do Docker init, then it will welcome me saying like, hey, welcome to Docker init CLI, and this utility will walk you through creating the following files. So it helps me create a Docker compose file, Docker file, and Docker ignore. So right now I don't have any of this file, which you can see it right here. Now, one of the best thing about Docker init is it automatically detects what are the files which is present, and then it automatically detects your application platform. So right now, since I have a py file, it automatically detects that it is a Python script which is suitable for my Python server application. So I'm going to select that. It asks me about, okay, what version of Python do you want to use? Definitely this is the well tested, verified, the latest version, so 3.11.4. So I'm going to pick up that. You just have to hit enter. Which port do you want your app to listen to? So I'm going to make certain changes here because I want to list it in port 8080, just not to conflict with the other services. And then what is the command? So I will say like, okay, simply I will say python.app.py, python3 app.py, and once I hit it, it basically creates all these three necessary files: compose file, Docker file, and Docker ignore. So let's look at what is in Docker file. Now, if you see, this Docker file is basically created keeping the best practices in mind, and you can see it right here, where there are few of the environmental variable like Python, which version of Python, and then running is as a normal user rather than the root user, and then there are few of the mount points which you know, might or might not be required at this point of time. And then you have a user specify. I'm copying the source code, the app.py, from my host machine to a Docker container, and at last we are like exposing in port 8080. That is what I specify. Now for me, it would be really simple to see the compose file first. Now, if you look at the compose file, as compose file helps you create a microservices architecture with the front end and the back end. So right now I'm not using any of the databases. So everything is hash share commented. And the only thing which it added is basically the service. It created a new service by the name server. It highlighted the context that your Docker file is present in a present working directory and the port which is like 8080. So let me go ahead. So even without writing any code, I am able to bring up this application, something like this. So I say Docker compose up -d -build. So it is going to go ahead and build the image and ensuring that because we have specified the context, right? So it will go ahead and build these images and ensure that this, I can check it with the Docker compose PS. And if I go and do a curl 8080, I can see that hello from Docker. So you can see that without even writing any code, I am able to bring up the hello world application based on Python. Now, just like that, we have a couple of other examples. We have an example for Rust, right? And all these instructions are given here. So if you click on the Rust, this is very recently which I have added, the hello world Rust demo. You can always go ahead and try it out. Now the similar kind, if I really want to look at the dashboard, I can click on the dashboard. I can see there is a container which is up and running. Now, if you look at Docker Desktop provides you with a dashboard which helps you to see the logs, right? You can see here the server has started. Even I can see the bound mind. I can even get into the terminal and I can play around with this. So you can see my whole application is sitting right here. I can even go ahead and edit the files. And that is where your container file explorer, I do have a slides for it. And I can also look at the stats, right? So Docker Desktop gives you the complete, the flexibility where you can go ahead and even edit the files then and there. Okay. Now, coming back to the slides, let me see. Okay, so this was a demo with Docker init. Let's jump into the next section, which is Compose Watch. Okay. Now, what is Compose Watch? Compose Watch, if you know the Docker Compose, basically it provides you. Docker Compose is a tool which helps you to build a microservices architecture. So when you have one application or say service, you build it with the Docker file, right? You run that particular application using build it with the Docker file, and you can run it with Docker run. Docker Compose is required when you have a multiple services and you want them to talk to each other, say front end, back end, and they are talking to each other. Now with the Docker Compose, one of the difficulty which the developers were having, like every time they make changes in a services, they have to manually go ahead and rebuild it, and that requires two steps. One is you stop those services, right? And the next one would be with the Docker Compose down, you just go ahead and bring down your services, and then you make certain changes, and then you again have to start it. Now with Docker Compose Watch, what happens that this tool, so Docker Desktop, what it does, it automatically updates your Compose services container while you work. So Docker Compose will be continuously watching your file system, and if there is any changes based on the set of the rules, it will go ahead and perform that action. Now how it works, so automatically it builds a new image with a build kit. So what happened that when you make any changes, say in the requirement.txt file, so what it will do, it will try to build a new image with the build kit and then replaces the running image container. And that is so quick that that is so quick that it ensures that you don't have any kind of a downtime here. And in a Docker Compose file, there is a new section which gets added called as xdevelop section to your service, and that we get added. So on the right hand side, you can see here we have services in the similar way. There is a service called as a web build. I am saying dot, which means that it will pick up the Docker file from a present working directory. There is a command called as a npm start. So if you really want to start, your Node.js based application, but at the same time, we have a new section called as xdevelop, and I'm saying watch. Now there are two different actions which I'm going to talk about. One is sync, the other one is rebuild. Now sync is useful when, say, you want to go ahead, you are using a bind mount and you want to copy few of the files from your host system to your container. Now whenever I specify sync, what happens that whenever there is any change which happens on your host machine, because most of the time you will be coding on your host machine and you are copying it to their container. So whenever there is any change which occurs on your host machine, it basically syncs automatically to your container. So sync is more like you specify a path to watch for the changes in the host file, and the corresponding target path inside the container to synchronize changes to. So whatever the changes which you make in the host file, it gets changed into the container also. The other action is the rebuild, and this is really important. Now, say if I make any changes in the requirement.txt file, or any changes in the front end or the back end, right? So automatically it will try to rebuild it, because now you have the new package which you have specified under the requirement.txt or the Python module, right? So it will automatically try to rebuild. And requirement.txt under the Python and package.json under the Node.js is the most used uh, uh, file, because you make a lot of changes based on the new modules which you introduce. Okay, now to see it in action, I am going to pick up an example called as Docker samples awaiter. So let me so this is a kind of a very small sample application which you use for the Docker demonstration. It consists of Python web API backend to generate the avatars, and a JavaScript single page application front end. So what I'm going to do, I am going to just pick up this particular application. So what we can do right now, so think of it as like uh, I can just clone this application. So let me come to the demo, and let me see if I can clone this. Okay. Uh, okay, so I am going to clone this particular awaiter application, and you can see it here that we do have a compose file which is right here. So this compose file basically has number of services like the API and the web, right? And you can see here we have specified the X develop, and we are saying like whenever there is any changes in the requirement.txt, you rebuild this application, right? And this is successfully hosted in port 7535. So let me go ahead and say docker compose up -d, and it will start this particular application. So I can quickly see this, and you can see here it is, the application is running on 5735. Let me go ahead and access this. So I will go to the localhost 35, and I can see this particular avatar application. I can change the facial here. If I want to make it as an angry, I can see I can make it as angry, or say I want to change the head. Definitely it doesn't look good, the astronomer and all these things. Okay, so I have this particular application running. So which I can see it as comport ps. And now say if I'm start, so since this is kind of a very early access and alpha bit, so I'm saying docker compose alpha watch. So it start watching, as I said, right? Watch command is experimental at this point of time. So it is basically watching the two of the files, as I said. Okay, requirement.txt. So let me open a new window here, and let me see, we are in a different directory altogether. So I will go to the demo and avatars. Okay, and I will go to the API directory and make certain changes in requirement.txt. So think of it is like if I say, okay, flask, if I want to add a flask to requirement.txt file, now you will see that once I run this command, there is a change which is detected in the requirement.txt. And as you know that in the compose file we have specified rebuild, so it is going ahead and rebuilding this application and ensuring that this application is still up and running. You can see here it is still up and running, so which means that I don't really have to go ahead and rebuild it from the scratch or manually, right? It is already there. And you can see here that it was watching this particular requirement.txt. I went to the API, made the changes. So the moment you make the changes, it detected the change which was made in this particular file, and then it tried to build it, right? So it started rebuilding this API. Okay, looks cool. Now, going back to our compose watch, the last section which we are going to talk about is Docker Scout. And if you are really working in the security domain and especially securing your supply chain, I think this is one of the section which you can't miss out. Okay, so let's talk about the Docker Scout. Now, what happened that whenever you build a Docker image, most of the time it happens that we followed the best practices um, in terms of running it as a non-root user, then picking up the linear images ensuring that we have a multi-stage build used for optimizing your Docker image. And then we have an open telemetry. But one of the major thing, or the main components which we forgot, is sports, especially the security. Now, if you would look at the Docker file, we are picking up a base image in very from Docker Hub, but from a very random kind of releases, right? I just go ahead and pick up the latest image or specific image, but I don't know from where these images are coming, which are the files which is available in that images. So most of the time, what happened that we started in an ecosystem where you have a producer and consumer, and we know that we are trying to there are like Node.js community is basically building those the application or basic packages, and they are pushing it to Docker Hub, and these are available to me. But I don't know what is the history behind, who is basically packaging it, who is who is um, who is building or writing those files. It is everything is happening in the community, right? So it becomes important that whenever you create a Docker file or Docker Compose file, you have to ensure that it has to be secure. Okay, so Docker Scout provides you with the capability where it secures your supply chain, especially the producers till consumer, the end to end. So Docker Scout gives you that kind of a capability where I can basically go ahead and secure my container development right from the day one. And one of the major focus of Docker Scout is it does a layer by layer view of dependencies and their known vulnerabilities. So it knows about what are the vulnerabilities which occurs on each of these layers, and these each of the layers might have different kind of a packages, different kind of a secrets, environmental variables. So Docker Scout ensures that those images are secure in nature, right? So it is designed with developers in mind, because most of the time what happened that when we talk about DevSecOps, as you know, the security is a major part, but that comes later point of time. We call it as so later point of time. Once you build it, you push it. So initially what used to happen that when you build an image and put it to the Docker Hub, then after that we used to run a scanning. But with the Docker Scout, the security or the vulnerability check happens right on your desktop, right? And I'm going to show you. So it is a first class citizen today, which means that we do have a Docker Scout as a command, which is rightly integrated with the Docker desktop. It sits as a layer on top of your Docker ecosystem, which means that when you start building an image right there, Docker Scout gets enabled, right? Definitely you can go ahead and control it, but by default you will see that it is enabled, and you can build a secure supply chain. And the whole intention is, as a developer, you should spend less time in fixing the vulnerabilities and more time in the development. Now, with the Docker Scout, there are three basically areas which we are targeting. One is observability analysis. So with the one view, you can see which are those vulnerabilities. Then we have vulnerability management. There are specific CLI commands. So whenever you detect that, okay, uh, so Docker Scout is different from other scanning tools, because here we are not just scanning it. We are comparing it with the SBOM, which is just like software bill of material. Think of it as like an apparel. Yeah, you wear an apparel, you get a tag, and this tag has all this information. What is the percentage of cotton it has, what is the size of the apparel, right? So in the same way, we have an SBOM, which is just like a tag on your Docker image, which has a Docker image manifest, which has all the history of from where it has come, who is the producer, who has been using it, from where it has been packaged. So all those packages, files, all this information is available in the SBOM, especially in the image manifest file. So whenever a new CV is released, which is basically a critical vulnerability examination report, Docker Scout, we use your SBOM and compare it with the CV. So we have an integration with multiple, like 14 to 15 different real-time CVs, and it gives you an information. So rather than just scanning the application, it basically comparing it with those CVs. And the third thing is, we are not just allowing you to know what the vulnerability is, but we are also giving you the remediation. What is the remedy, what packages can fix that? So all this information is already there. Now, to show you a quick demo, I am going to directly jump over one of the example. So I have Scout demo service, which I have cloned it from Docker samples. And the first thing is, you need to go ahead and install the latest version of Scout. So what I'm going to do, even you can run it on a Linux machine. It doesn't have to be on Docker Desktop. But since I'm using Docker Desktop, what I'm going to do, I'm just going to go ahead and install it on my machine. So what I'm going to do here is I have a Scout demo service with this particular curl command. So what I can say, Docker is Scout version, and it specified that this is very latest version, which I have just upgraded yesterday. And now I've ensured that I have the latest version of 0.22.3. Okay, going back. Now I will clone. Yeah, I have already cloned this, and you can see under the Scout demo service, I have a very simple Docker file, which is basically I'm picking up from the base image, which is Alpine 3.14. Definitely, it is an old one to show you what vulnerability we can produce it. And it is very simple, as we have already seen the Node.js based application. It is running app.js, and it is again a hello world example exposing in port 8080. So what I'm going to do, I will go back and pick up, okay, Docker build Scout demo, and this time I am going to pick up v2. So let me pick up v2, and I'm trying to install a version 2, just not to conflict it. And once you build it, you will see here that view the summary of image vulnerabilities and recommendation by Docker Scout quick view. So quick view is a quickly it will show you the vulnerabilities, right? So let me go back and try to see, and if I really want to run this specific application. So one of the change which I'm going to do right now, I am going to build it with my org name so that it becomes easy. So my org name is Collabnix, and this quickly happens, right? And if I really want to run this, so how does it look like? So I am going to say Collabnix Scout demo v2, right? And it will run this particular image. So I already have, definitely there is a more way, right? I'm just running this application. Let me see if I can stop this application, which I have which I have been running in the past. And once I stop this, because I have the Python, you remember with the Docker init, we build a kind of we ran a Docker container with the same port just to ensure that it doesn't conflict it. So right now, if you see, I don't have anything running on port 8080. So let me go ahead and run it again. And it says that there is a conflict. So let me stop this. Hang on. Docker. So what I'm going to do, let me go to the Docker file and make these changes. So say if I want to expose in port 8081, let's see what happens. So let me build it again. And then this time I am going to run it on, say, okay, let me, okay, anyway, I'm running it in port 3000, right? So let me go back into init and stop this particular service. So I'm going to bring down compose and just see if there is anything running here. It says that, okay, so I'm going to clean up this particular service just to have a clean example. So right now, if I say docker ps, there is only one of the service which is running here, right? Now, take an example. I can always go ahead, do the curl command and see whether it works or not. And it says hello world, which is good. So under demo, let me go back to Scout demo. And here I can see that my application is up and running. Now this looks good. Now what I will do, I will just go ahead and push this particular demo file which I have created. So you remember we created a v2. I will just pick up the org and I will push it to my Collabnix account, right? So if you see, it is pushing it to the Docker Hub. Now, if I go to the Docker desktop here and look at the dashboard, one of the things which you can see here is we have a container, we have the images, and we have a hub. Now, under the hub, I have different organization called as Collabnix, and you can see here right now I have both the version v1 and v2. I click on v2, it is still taking time. So right now, if you see, I have already pushed it, right? Now, one of the thing what I need to do here is right now this image is not analyzed. The reason being I haven't, the scout is not enabled here. So what I'm going to do, I'm going to enable the Docker Scout here. So what I'm going to do, I'm going to say the org name as Collabnix and Scout demo. So once I do this, you will see here that soon there is vulnerability check which has enabled, and I can see it on the containers. And you see on the one which is marked red is basically the critical vulnerabilities. There are two of them. One is in the layer 5. There are two packages which holds the vulnerabilities. One is Express and one is QS. Okay. Now, if you look at this Express, it says, as I said, right, Docker Scout just shows you, it detects the vulnerabilities, but at the same time, it also gives you the remedy. The remedy is right here. Once you click on CVE, it says like, okay, there is a fix in version 4.17.3, right? So what I'm going to do, I'm going to go back and open package.json file, and you can see here under the Express, what I'm going to do, I'm going to go ahead and make those changes right here, 4.17.3, right? I'm going to use same docker build command, and this time again I am going to push it to my to Docker Hub under this particular org, which is Collabnix. Okay. Now, once I do this, and once I refresh this, most probably it should solve this problem. The layer 5 should not appear as highly critical. So let's wait for some time. I'm just going to click on the images, go to the hub, Collabnix, and V2, and you will be able to see here that it's still analyzing the image. So let me see the status. Okay, it has already pushed it. It will take some time to go through it. And if you see the layer 5, right now there is no vulnerability here, right? Now still there is one vulnerability which you can see in the base image, which says like, okay, this is highly critical, because we need to ensure that all those high critical as well as the critical and the high vulnerability has to be fixed. So still the vulnerability is not fixed. We are able to fix only one. Now, if you look at this particular vulnerability, I can check the CV, and it says that there is, if I click on this and say recommended base fixes, it says that you need to go ahead and change the base image, and the current image is 3 dot something, and then it says like, why don't you go ahead and change it to 3.16. Okay, so what I'm going to do, I'm going to again go back to Docker file, copy it here, and remove this, right? And then see whether it at least it detects, is basically remediate my high critical component, right? So once I make changes, definitely it is going to take time. The reason being, I changed the base image and the latest image of Alpine. So still we are not in the latest image, is like a 3.16, right? So Scout is saying like, okay, you need to go ahead, because right now we are not just talking about the vulnerabilities, we are also talking about the remediation, right? So right now we just change the base image so that the OpenSSL packages, every new image or base image comes with the newer image of OpenSSL in most of the cases. So that will probably fix our problem. So right now I have already done that. I will just push it to my Collabnix org, and let's check after some time, and let's see if it improves. Whenever you make certain changes in the base image, it is going to take time, because now uh, it starts from that. It first pulls those the latest base, especially the specific version of the base image, and then it tries to go ahead and build those images. So right now, if you see here, I go to the if I click on container images hub and then Collabnix, you might see that uh, most of the vulnerabilities has already been fixed. So there were two vulnerabilities, and it was easy with Docker Scout to go ahead and fix those vulnerabilities, right? Now, definitely you can visit Ajit Rana /scout demo service to have a view, and I have noted all the steps. Looking at the time, since we have just 10 minutes and 5 minutes for Q&A, one of the other thing which I want to say about the GitHub action. So we do have an integration with the GitHub action. So in the same repo, if you go to Scout demo service. So I have one of the slides which talks about it. Let me see if I can find out. Okay, sorry, I don't have that. But one of the last item which I want to talk about is under Docker samples init demo and a Scout service. There is a workflow file which we have included. So think of it as like most of the time when you build it, if you are using a CI platform. So right now we do have a support for Jenkins, GitHub Actions, GitLab, Microsoft Azure DevOps Pipeline, right? All those CI platforms are supported. Now, giving an example of uh, especially the GitHub action. So right now, if you see, this is a workflow file where I've specified, okay, this is my Docker image, and there is a section called as Scout CV where I'm specifying that you accept those pull requests only when you don't have the especially the severity in place. So think of it as like one of the example which I could give here is if you open Scout CLI here. So I will just open Docker. So github.com Scout Docker Scout CLI. You will see here there is a workflow which is defined, and in this workflow, let me see. Yeah, so this is one example of the GitHub action here, which it says there is a section called as Docker Scout, which is specified that if the severity is critical or high, right, you don't really have to go ahead and do the pull request. So whenever you push any changes to the GitHub, first thing it is going to do with this particular workflow is it will try to check whether your Docker image, it will try to build it and check the vulnerability is high or critical. And if it is high or critical, then it won't merge it. So those kind of you can basically control your pipeline using this. So for this example, I can show you quickly under Docker Scout sample demo. I can pick up one of the. So this is very recently which I have picked up, which basically shows you right on the GitHub action. You can see the vulnerability right on your GitHub action page itself. So you can see here the integration of Docker Scout with the GitHub action in the sum that in the way that there is a vulnerability and you can report it right here. I can clearly see the same kind of a vulnerabilities here. This is version 1, which we try to fix it. So right now it is fixed with 4.17.3. This is basically the fix. So what I'm going to do, I'm going to make the changes, push it to GitHub, and then it is going to fix it. And the next fix, as we have seen, right, we fixed it with the latest version of Alpine. So that is where you can do it. So very similar case, if you are running on your local, it is very easy, you can do it. But if you are using it, if you are pushing your code to the GitHub action or GitLab or Microsoft Azure pipeline, that is also possible. And one of the other example which I want to show here is if you go to Scout CLI page, you can see the specification for each one of them. For the GitLab, if you see, we have this particular entry, right? For we even support Circle CI, right? So I'm planning to write a blog post on each one of them. And then we have a Microsoft Azure DevOps pipeline. You can definitely leverage this particular workflow even for the Jenkins. Now, so with this, I am towards the end of this session. I think I have already talked about each of the stuff. So one of the important thing is if you really want to get connected to me, you can join my Collabnik Slack channel, which has around 8,700 members. We talk about Docker, we talk about Kubernetes, IoT, and most of the meetups which you see are basically discussed and operated through Collabnik Slack. So with this, I think I'm done with the presentation. Over to you, Parth.
Hey Ajit, it was a fantastic, wonderful session. Hope all viewers took the learning. So here are the few links that would help them for the further learning. I'd like to share them.
Mm-hmm.
Okay. Yes.
Do we have any questions?
Please do ask questions. Final call to ask the questions as we are at the end of the session. So I have posted few links which can help you to take your learning further. So Ajit, I think we have one question from STEM
Mhm.
codes. They're asking, will Java also be supported in the future?
Yes, so we do have a plan to support .NET and Java, since we have, because the Java community has been like immensely, they have been using Docker as a tool. Especially, I have used in one of the pet cleaning application where I've used Java-based application. So yes, we do have a plan to support, and we do have a Google form where if you go to docs.docker.com, in a Docker init page, we do have a form where you can submit that which application platform do you like us to go ahead and support. So definitely we are open for all those suggestions coming from the community.
Yep. I hope this answers the question. Yes. So thank you, Ajit. Thank you so much. Thank you. Let's see you soon again on a different topic. Yep. Thank you, viewers. Thank you so much.
Thank you all for joining me. And if you have any questions, you can either ping me on the Slack as well as in LinkedIn and Twitter. Thank you so
Yeah,
much for your
I'd
time.
like to share your LinkedIn handle.
Okay.
Yes. Please do reach out to Ajit Raina for any questions on Docker, Docker DevTools, Docker containers. And yes, thank you, Ajit. Thank you for doing this. Thank you again. Thank you, everyone. Thank you.
Yeah. Thanks, Parth. Thanks, everyone.
Thank you.